Okay, so let's see, what are we dealing with? So for every character, get a sample. Like that. So I'll process these in order. Right, so I'm gonna go through all of the characters in S. And our base condition should be to say stat output. Characters we just, yeah. Or is it push? Yeah, it's push. We push the stack these characters. So for example, the first case on our stack we're gonna have, so this is the stack. Wait, I need a way because we can't use the brackets, it's gonna get confusing. I'll use the apple brackets to be the stack. Okay, so we have the first character, just this open bracket, and then when we come across this closed bracket, we want to cut that off. There we go. Okay, yeah, so I'm gonna mark that off. So when we come across close bracket with this, we want to check if it's there. That's annoying. So yeah, we're gonna check that that was there. Since both are in the stack, then we've found a valid parenthesis. Okay, so we can take that off. So yeah, so we want to say if lookup contains key ph if stack isn't empty. So say if not stack dot is empty, and lookup this stack it be turning back. I'm missing something here. Yeah, let's try for something like this. Okay, so first iteration, I'm gonna add this. Yeah, so let's see. First iteration, we're gonna add this bracket. Checking if the stack is empty. We don't have this. So do I put an okay? I don't think this will work. So, no. Oh, wait, it's because of those. Very out of practice with stacks. Okay, so let's evaluate this. Why is this evaluating to be true? Okay, so we're not filling it correctly. So for every character in S, we want to assert that say if S, if our stack isn't empty, and pop from our stack. Else if or else what? So if we don't have an empty stack, oh, thank you, man. Thanks for the sub. Catharsis, thank you for the sub. I appreciate that. Gonna hit 100 subs before Christmas. Okay, so lookup contains key. Wait, let me open my chat properly. Okay, so turn stack that is empty. So if the stack isn't empty, so if we have elements in the stack, otherwise we could say that we want some. We push the character now. I think the only thing I'm missing now is some condition to check if it's not a valid character at all, right? The catharsis is gone now. Okay, so let's say, so if our stack maybe like this. Let me just erase a lot. Okay. So starting from the beginning, so I want to know if we have character. So if lookup contains our bracket, we have our bracket, and if our stack isn't empty, so stack isn't empty. So our stack isn't empty, and we have the character. We want to remove what's there, so we would say stack pop in the stack. Otherwise, if we have a case where stack isn't empty, so say we have this in our stack, so we have this character, stack isn't empty, yeah, that's fine. Just if we yeah, we'll use the invalid case that we're given. So yeah, this is when the return false, because say we push this, so within our stack, let's say our stack is this. Okay. Within our stack we have this now, this single bracket. We have that in our stack. We've pushed that. And then we're gonna evaluate, get to this bracket. We're gonna get to that bracket, and then we're gonna have to pop from the stack. And if we pop from the stack, we're gonna still be stuck with this, because we're still gonna have to add this in. Then we're gonna get to the end, and the stack is gonna be full still, or not full, still gonna have elements in it. So okay, wait, let me just like finish this solution, and then we'll draw something up. So yeah, if we don't get to remove an element, or if the stack isn't empty, well, maybe no. Okay, so if the stack is empty, and we have an element from here, so yeah, if we have a closing bracket, because we use the closing brackets as the key, so if we come across a closing bracket and the stack is empty, that means we don't have an opening bracket on the left. That means we have to return false. Then outside of this, we would add to our stack. Or right here we could add to our stack. No. In need a revision. Okay, we're still wrong somehow. Oh, okay. Yeah, okay. So what we need to do here is we need an else to this if. So if lookup contains key, so if it doesn't contain the key, then okay. Feel like we're closer. Wrong now. What is the matter? Contains key. Stack is empty. Open the stack. Otherwise return false. Else push the character. Do I just have something really wrong somewhere? Or am I close and I just not seeing? Let me just reset one more time. Okay. So, character. Every character in our given array so for every character ch in s. So every character ch in s. I'm gonna check if our lookup contains ch. Okay. So if lookup contains the key, so if our map has the closing bracket, the character that we're at, we find a closing bracket, we want to check if the stack is an empty, so if not, that. And we say if lookup dot get ch we say if the stack contains it, or say if, yeah, I think I got it. So if lookup .th equal to the peak of the stack. So we're checking if the open bracket is on the other side, then we can pop back up pop. Otherwise, we would have to return false. That would mean there's another character or the wrong character on either on the other side of the bracket that we find in the map. So that would be an invalid parentheses. So we would have the wrong two parentheses. We could return false. Then in this case here, say else. But here we just return whether or not the stack lovely. There we go. That took way too long. Is that not optimal? Oh. I thought the solution should be optimal. It's all then. At least. It's probably the nested if that makes it different. Oh. I got it at some point. I don't know what the difference maker was. Somehow forgot how I did it. Next problem. GitHub. Let's mark that off. Yeah, merge two lists. Okay. This one shouldn't be as bad, hopefully. I need to remember to reset these because I have a lot of these done from the past. Just not gonna look. Okay, so two lists are sorted already. We just need to merge them. So going from one to another. Oh, okay. So base case, let's just say if list one no equal to null, we can just and if list two is not equal to null, this one is equal to null. Yeah. So what I want to do now is create a node called dummy, new list node 0. Essentially, this is creating a brand new node with a value of 0 over here. So then I can just add. So for this example over here, I want to be able to do something like 1, 1, 2, 1, 1, 2, 3, 4, 4. Okay, in that exact order. So yeah, so and then just return everything after this. The reason you make the dummy node is so we can simplify boundaries, so we don't have to worry about nulls as much. So say while list one and list two are equal to Pick the lowest value. So you need to compare the values of the two, add the lowest to current. Let me not distract myself. Okay, so list 1 is not equal to null, list 2 is not equal to null. Wonder, I don't have to worry about next nodes or not, maybe, I don't know. So while each one, I just want to check. Just need to decide which one gets picked over the other based off of which value is less. I'm gonna be adding. Yeah. I was saying if this one about less than this two, so and equal to make a new node or no. Wait, and dot next is equal to this one. We use an else then. Yeah, so it's saying it's either gonna be one or the other every single time. There's no else if. We just then end dot next equal to list 1 dot next. Then we would say that tail end is good. Oh. Actually, no. Here we would say list 1 is equal to list 1. And then list 2 is equal to, and here we would say so we keep going up that way. And then if we get to the point where more of the list is left, so say one list is completely finished and the other list is there, I think we have to just add the rest. So then would it not just be if list 1 not equal to null, list 2 is equal to null, say dot next equal to this one. me see anything else. Or rather, I don't know. One person. And then we would just return wrong here. Oh, should be dealing with nodes. Maybe it should be nodes. Yeah, cool. Yeah, that one wasn't so bad. Yeah. Yeah, I know it's only 36 minutes in, but I actually have stuff to do. So, sorry. I might stream tomorrow. I have content and stuff to film today, so and stream.